Question 6 is not related to the picture underneath. We have a toy car. It has an acceleration in that direction for a delta t of 5 seconds. Could the use to determine the average net force exerted by the car during 5 seconds? So F net equals ma, and we know the net force is delta p over delta t, and that is going to be m delta v over delta t. So we want to know the net force. That is by definition ma. The net force is also delta p over delta t. So use a meter stick and a stopwatch to measure the distance the car travels for 5 seconds. So if we know the distance, the delta x, and the time, and we know there's acceleration going on, we could try to use an equation like x equals 1/2 at squared plus v0t plus x0. Now keep in mind we're looking for the net force. So to do that, we need to know the acceleration and to need to know the mass. Now it doesn't tell us the mass. We're not given the mass. The delta, and so it looks like it is probably not doable from this because we also need the mass. And if we looked at this equation, x equals 1/2 at squared, well, we could set that equal to 0. But it doesn't say it's from rest, so v0 is unknown. We know t, and we know the x, so we could find the acceleration, but we don't know v0, we don't know if it started at rest. So there's just too many unknowns for it to be A. Moving on to B, so this gives us the mass, and a motion sensor to measure the speed of the car at time 0 and a time of 5 seconds. So F equals m delta v over delta t. The motion sensor is going to give us delta v and delta t in the balance. So it looks like choice B is our answer. So let's continue to make sure. Mass of the car, check. The distance the car. So you can see the difference between B and C is that we don't know V0. So C is out. And motion sensor to determine the speed of the car at 0 and 5 seconds and the distance. So again, we still don't have the mass. So choice B.